Hello, my name is Maria from mathmammoth.com. In this lesson, we're going to talk about the volume of pyramids and cones. Now, first, what is the definition of a pyramid mathematically? Here you see several. A pyramid has a polygon as a base. So here, for example, is a hexagonal pyramid because there's a hexagon at the base. And then here's one point called the apex of the pyramid. And all of these vertices or corners of the base are connected to the apex. And then we get these triangular faces here. Each pyramid also has a height, which is a line segment that is perpendicular to the base and comes from the apex. And a pyramid can be slanted or oblique, or a right pyramid if the apex is exactly above the center of the bottom shape or bottom face. This here is what? Why is it there? It's the net of a certain pyramid. So if you fold it in three-dimensional space, if you print it out and fold it, then you will get some kind of a shape. And in this case, it's going to be what? 1, 2, 3, 4, 5, 6, 7, 8. This here is an octagon, so an octagonal pyramid. And what is a cone mathematically? Here you see one, but have you ever thought of what is its definition? In a cone, we normally have a circle at the base. And then we once again have one point, apex, over here. And then it just kind of tapers down from the base all the way to the apex. And there ends up being just one other face over here wrapped around. Here's one definition. A cone is a three-dimensional solid that tapers smoothly from a flat base to a point called the apex. This one here is actually a double cone, and instead of a circle at the base, it has an ellipse. It's an elliptical double cone. This one here is the net of a certain cone. It kind of looks interesting. You might not at first sight realize that it's the net of a cone. But notice here is the base. It's a circle. This is the other face that wraps around, and over here is the apex. You will really best see it if you actually cut out the net of a cone and fold it to a cone. The volume of both pyramids and cones is the same. It is 1/3 times the area of the base times the height. Let's look at an example and calculate the volume of this particular cone here. It is a circular cone, even if it looks like that it's an ellipse at the base. I am intending it to be a circle. How would you calculate the volume of this? Well, it's going to be the area of the base times the height, and then divide by 3. If you don't divide by 3, then you would get the volume of a cylinder with that base and that height. So 1/3 times the area of a base. In this case, the base is a circle. So once again, we use the familiar formula pi r squared. Another one you need to memorize. Pi r squared. R is what? This is the diameter. That's commonly how these geometric figures appear, that we are given the diameter, not the radius. We need to take the radius, which is 31 centimeters, and square it times the height, and make sure the 1/3 is still there somewhere, or a division by 3. So we get about 89,565.759. What is the unit? We have volume, so it's going to be some kind of cubic units. And we have centimeters squared times centimeters, so that's cubic centimeters. But we need to round this some more, right? How? Use the rules of significant digits. Here's 2 significant digits here also. So we'll only keep 2 digits here, 8 and 9, except that the 5 makes it round up. So we actually get 90,000 cubic centimeters. All right, let's solve another different kind of problem. This time we are not just going to calculate the volume of any shape, but instead we need to find the height. The volume of a square pyramid is 50 cubic meters, and the side of its base measures 5 meters. What is its height? We know the volume, we know the side length of this base. Do we know what shape the base is? What kind of pyramid is it? It's a square pyramid, so we do have a square here. 5 meters, and then, I don't know how high it is at this point. It does have a height. Let's mark it with H. The area of the base is 25 square meters. That's easy. The volume is 50 cubic meters. Now recall the formula. The volume was 1/3 times the area of the base times the height. And that whole thing equals now 50 cubic meters. The area of the base here is 25 square meters. Then the height. I think we can solve this with mental math because we have these easy numbers 25 and 50 here. Okay, this 25 and 50 means that these other two have to equal 2, number 2. Okay, so that we get 2 times 25. If you want to see it more clearly, maybe like this. 1/3 times the height times the 25 equals 50. I'm omitting the units just for clarity when we're thinking of it mentally. This here must equal 2. Then we get 2 times 25 equals 50 and everything matches. So some number divided by 3 has to equal 2. What's that number? Yeah, it is 6. The height must be 6. What units? Since we have cubic meters, square meters, then this must be in meters. 6 meters. So it's a pretty good sized pyramid here. Well, not compared to the Great Pyramid, but compared to, say, a room. All right, we're all done with this lesson.